Okay, we have three rules for the definition of the derivative. What we want to do is, instead of actually calculating this limit, we just want to recognize that that's the derivative of some function. Now we can't do that with this one on the bottom because the limit on the bottom is not the derivative of a function. Here we're calling it bogus. Now that doesn't mean it's a bogus limit, it just means that that's not the derivative of a function. Now here you can see the function is 5x to the third. Everything matches up. You have x plus h inside. So this limit is really just equal to the derivative of 5x to the third. We can solve that really fast. The 3 comes down, and the new power is 2. And that's what your limit is going to equal. Okay, same thing here. On the bottom, you see it's an example that does not match up. We should have the limit as h goes to 0. We have the limit as h goes to 2. That's not correct. If you look right here, it kind of shows you that this is the derivative of 5x to the third, but it's when x is 2. So again, this limit is equal to the derivative of 5x to the third when x is 2. So that would give us 15x squared when x is 2. Then we plug in our 2, we get 15 times 4. Final answer here is 60. So again, instead of doing this limit, which would take a really long time, we're just recognizing that it's just the derivative of this function when x is 2. So we do the derivative of the function, and then we plug in a 2 for the x. Okay, I think you can notice that the bottom one is wrong because the bottom should be x minus 2, but it's an h. So this is not the derivative of 5x to the third. Now comparing it to this formula up here, you can see that this limit is the same thing as the derivative of 5x to the third when x is 2. Now we just did that on the previous page. We got 60. Well, what's different about this one? Well, we're just using a different limit formula. Okay, so this limit is equal to 60. Okay, on the bottom limit, you can see it's supposed to be x plus h, but it's just an x. So we're calling that bogus. Again, it's not a bogus limit. It's just not the derivative of cosine. This one is the derivative of cosine of x when x is pi. Derivative for cosine is negative sine. Now we still got to plug in the pi for the x. Sine of pi is 0, so our final answer is going to be 0. So that means that this limit is equal to 0, and we never had to actually do the limit. We just recognized that it was the derivative for cosine when x is pi. And that's an easy derivative to do. Only takes a couple seconds, and then you plug in the pi. Much easier than doing that entire limit. Okay, this is just the derivative of 3x squared. That's just the power rule. So the power of 2 comes down, and the new power is 1. And that's your final answer. Again, we don't need to do this entire limit. That would take a long time. We just recognize that that's the derivative of 3x squared. And then we do the derivative of 3x squared. Okay, over here, if you ignore the h, you'll see that this looks like 3x squared when x is 10. Now we still got to make sure that it works. If this function was 3x squared, then when x is 10, you can see you would get a 300. And we have a 300. So this limit does equal the derivative of 3x squared when x is 10. Okay, we can do that derivative really fast. You just get 6x when x is 10, and you plug the 10 in, you get 60. And now we're done. So this limit over here is just equal to 60. Here, we're using a different definition of derivative here. It's the third one that we learned. You can probably see that the function is ln of x. So we're doing the derivative of ln of x when x is 3. Derivative for ln of x is 1 over x. And if you plug the 3 in for x, you get 1 over 3. And that's your final answer. So this limit is just equal to 1/3. Okay, if you remember the rule for the derivative of sine inverse, the example we're doing, instead of an x, it has an e to the x. So that's the only difference. So when we do the derivative, we just pretend it was an x. You plug that in right here. But then we say, wait a minute, it's not just an x, it's an e to the x. So we have to do the chain rule. We have to do the derivative of e to the x. Now, the derivative of e to the x is just e to the x. Now, remember, you don't have to simplify. But if you're trying to make your answer look like one of the multiple choices, then you kind of have to. So what do we do with e to the x squared? Now let's take a look over here. Remember, e to the x times e to the x is going to be e to the x plus x. So that's the same thing as e to the 2x. Another way to think about it is that you have e to the x squared. The way that I remember it is when these two things are next to each other, you can just multiply them. So this is going to give us e to the x times 2, and that's the same thing as e to the 2x. So this part down here is just going to be e to the 2x. And now we're done. This is the final answer. Okay, this is just about notation. If the function was f of x, then when we do the derivative, we would write it f prime of x. But if we also wanted to plug a number in, like 2, then we would write it as f prime of 2. You'll notice we have a 2 when you plug a 2 for the x. We have an x when you leave it as an x. So when it's f prime of x, you'll notice there's an x there. When it's f prime of 2, the x has been replaced with a 2. So make sure you understand the difference between f of x, f prime of x, and f prime of a number. A common mistake that we notice on the AP test is that people combine these two things. They write f prime of x, but then they plug the 2 in. And this is really bad notation. Okay, this is our last example. Now we have a rule for the derivative of x to a power. The power would come down, and the new power would be 1 less. We also have a rule for the derivative of a number to the power of x. That would just be 2 to the x, ln of 2. Now we don't have a rule for an x to a power that's also a function of x. Notice in this first example, the power was a constant, and the base was a function. We can do a problem like that. In the second example, the base was a number, a constant, and the power was a function. We can also do that derivative. What we don't have a rule for is the derivative of a function of x that's to a power that's also a function of x. Notice neither of those things are constant. So we don't have a derivative rule for that type of function. Now normally they give us the derivative just like this. Again, the base is a function of x, and the power is also a function of x. So in order to do this derivative, we're going to have to create an equation where we say y is equal to this, and then you'll notice our answer is the derivative of y, which is the same thing as y prime. So in the end, our answer will be y prime. Now we're not going to be able to do the derivative unless we can get this piece to come down. One of the tricks we're going to use is we're going to do ln of both sides. Now this power can come down in front of the ln. Here it is on the second step. Now you'll notice we can do that again with the x to the third. The 3 can come down. And you see the 3 in the front. And because this is just ln of x times ln of x, we can write it as ln of x squared. Now I want you to notice that we have not done the derivative yet. We are now going to do the derivative on both sides. Now on the right side, we're doing the derivative where x is the variable and the function is a function of x. So we're going to pretend that the inside is just an x, the 2 comes down, and the new power is 1 less. So the new power is 1. However, the inside was not just an x, it was a bunch of stuff. So we're going to have to do the derivative of that stuff. And that's the chain rule. Now the derivative for ln of x is 1 over x. Notice you can multiply the 3 times the 2 and you get 6. Now here's what I consider to be the tricky part. What is the derivative for ln of y? I want you to notice that it's the wrong letter. It's a y. We're doing the derivative where x is supposed to be the letter, and the letter is the wrong thing. It's y. So we're first going to do the derivative as if it was the correct letter. The derivative for ln of y would be 1 over y. And then we say, wait a minute, it was the wrong letter. So we still have to do the derivative of that letter, and that's the chain rule. The derivative of y is simply just y prime. Now, if you'll remember, in the very beginning, we said our answer was supposed to be y prime. And we have a y prime sitting there. So if we can just multiply both sides by y, we'll be done, because the y times 1 over y will cancel. Now we don't want a y sitting over here in our final answer, because our original derivative was a derivative of a function of x. So it doesn't make sense to have a y in there. So if you remember what the y is, you can trade the y for x to the ln of x to the third. After doing that substitution, we are done. Final answer, y prime is all that stuff. You can see the final answer is a pretty big mess. Now this is one of the tougher derivatives. I recommend rewinding this one, pausing it, making sure you understand each step.